So welcome students. So in this question you are asked to prove this identity, that is P of n is given as 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 plus so on up to 1 by n into n plus 1 into n plus 2 is n into n plus 3 by 4 into n plus 1 into n plus 2. So you are asked to prove this identity. Okay. So now we know the steps. So let us do the first step, which is the verification step. So in the verification step you have to check whether P of 1 is true or not. So P of 1 is nothing but 1 by 1 into 2 into 3 is equal to, the LHS is 1 by 1 into 2 into 3 is equal to RHS 1 into 4 by 4 into 2 into 3. N is equal to 1. If you substitute n is equal to 1, 2 into 3. So 4 and 4 gets cancelled. This implies 1 by 6 is equal to 1 by 6. Hence, P of 1 is true. So P of 1 is true. The first step is done. And the second step is assumption step. So we assume that P of k is true. P of k is true. Assume that P of k is true, that is 1 by 1 into 2 into 3 plus 2 into 3 into 4, so on up to 1 by k into k plus 1 into k plus 2 is k into k plus 3 by this. So third step is the proof step. So you have to prove that P of k plus 1 is true, that is 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 plus 1 by 3 into 4 into 5 plus so on plus 1 by k into k plus 1 into k plus 2 plus 1 by k plus 1 into k plus 2 into k plus 3. So if you have to go for n is equal to k plus 1 is equal to k plus 1 into k plus 4 by 4 into k plus 2 into k plus 3. So this is what you need to prove. So now let us go from LHS. So in LHS from here to here. So this is the LHS of P of k. This has been already assumed as, so k into k plus 3 by 4 into k plus 1 into k plus 2. So this part is this plus 1 by k plus 1 into k plus 2 into k plus 3. So that is equal to, so you can, if you want to add these two, 4 in k plus 1 into k plus 2 is the common denominator. I can take that as common. 1 by k plus 1 into k plus 2. If you take this as common, you have k into k plus 3 by 4 plus 1 by k plus 3. 1 by k plus 3. So 1 by k plus 1 into k plus 2 is taken as common. So you have k into k plus 3 by 4 plus 1 by k plus 3. So that is equal to 1 by k plus 1 into k plus 2 times. So if you take LCM here, you have 4 times k plus 3 as the LCM. So you have k into k plus 3 whole square. So k into k square plus 6k plus 9 plus 4 by k, 4 times k plus 3. So that is equal to k cube plus 6k square plus 9k plus 4 divided by 4 into k plus 3 into k plus 1 into k plus 2. So now this is a cubic expression, so it can be factorized by trial and error. So you can see that if you put k is equal to minus 1, so this is becoming 0. So k plus 1 is a factor of numerator. So if you put k equal to minus 1 plus 6 minus 9 plus 4, 10 minus 10 is equal to 0, and k plus 1 is a factor. So if you factorize this, 4 times k plus 1 into k plus 2 into k plus 3. So if you take k plus 1 outside, the quotient will be k square plus 5k plus 4. So k plus 1 and k plus 1 gets cancelled. That is equal to, you can factorize this into k plus 1 into k plus 4. So k plus 1 into k plus 4 divided by 4 times k plus 2 into k plus 3. So this is nothing but the RHS. So this is nothing but the RHS. So LHS is equal to RHS. Hence, the fourth step is the conclusion step, where we say that my statement P of n is true for all natural numbers. Hence, P of n is true for all natural numbers. So that's the fourth step. You can write it.